All right, I'm back. We're on page 1 of notes 27. It's partial fraction decomposition. We're trying to do integrals, but like to do it, we're going to need to use partial fraction. I already mentioned in the previous video, I spent a while. There's a trick. I'll tell you about it as we do each of these. I already told you about it, but we're going to use it as we go through, so it should be useful. All right, let's see if we can do this. So we want to evaluate the integral. The real issue is like decomposing it so that we're able to do that. So first, I see that both terms in the denominator are linear. What's less than linear is constant. So we're going to rewrite this, potentially, as a over x minus 1 plus b over x plus 5. If there was another thing, I'd put c over that and then d over that, and they just get worse, equals x plus 3 over x minus 1, x plus 5. All right, I'm going to use a cover-up method. So I look at a. The denominator of a is x minus 1. So I'm going to say, let x equal 1. Okay. And now this is going to solve for a. So a is going to be equal to. We go over here, we cover up x minus 1, and then we substitute a 1 for every x that we see. So we get 4 over 6, which is 2/3. All right. Now we're going to do it again. So we look at what's underneath b. It's x plus 5. What would make x plus 5 equal 0 is x equals -5. So we're going to be solving for b. So b is going to be equal to, we go over here, we cover up the x plus 5, and we plug in -5 for every x that remains. So we get -5 plus 3 is -2 over -5 minus 1 is -6, which is 1/3. It's really common to get the same denominator for a and b. So getting that is kind of like reassuring when you do the problems. And then we have to remember what we wanted to do. So we actually wanted to integrate this thing. So we have to integrate 2/3 over x minus 1 plus 1/3 over x plus 5. And you can see these are both going to be natural logs. So we get 2/3 natural log absolute value x minus 1, and then plus 1/3 natural log absolute value of x plus 5. And then, oop, got like a parenthesis, close, and then plus c. And then I'm like way over, so I'm gonna use some iPad magic here and move my whole answer over to the margin a little more, just so I have more space to work on the next problem. So should we check it? You can always check them on the calculator. So there's two things that you should know about the calculators. Let me share a calculator screen with you. The first thing is that your calculator can do partial fractions, but it does them in a weird way. So it's going to use expand. So menu 3 is expand, and then x plus 3 over x minus 1, x plus 5. You don't need to give it like an argument or anything. And we get this. So it's 1/3 over x plus 5, which we got, 2/3 over x minus 1, which we got. Then we could integrate the answer with respect to x. We get this. So the calculator does this annoying thing where it combines everything. So you're almost better off finding the derivative of your answer. But this one's simple enough that I think we don't really need to worry about it. So let's go back and try another one. So we'll see what we can do on this one. All right, you're gonna find they're like really similar. So here, you know what, I'm gonna just like extend it over to the side. I'm gonna say equals, so it's a over 2x minus 1 plus b over x plus 4. All right, so step 1, what is under a? So what would make that equal 0? It'd be x equals 1/2. So we're gonna say, let x equal 1/2. And when we do that, we're gonna end up solving for a. So a is equal to, we go over to this side, we cover this up. So that's what I'm highlighting. I'm highlighting the thing to cover up. It's the opposite of usually what you do. Then we have, all right, so 1/2 for every x that's left. So 3/2 plus 2 over 1/2 plus 4, which is what? 7/2, 9/2, so 7/9. Okay, do it again. It's really like, it's kind of repetitive. It's sort of nice, kind of like a Zen thing once you kind of like get the rhythm. So if I let x equal -4, because that would make x plus 4 equals 0. Then b is going to be, we go over here, we cover up x plus 4. Every remaining x is now going to be -4. So that's -12 plus 2 is -10 over -8 minus 1 is -9. So 10 over 9. Same denominator, comforting, doesn't always happen. Although I think you can always write them with the same denominator. Don't quote me on that. I'm not really sure. You know, do a million problems and see if it always works, or like come up with some general thing that you can actually like use to prove it. So we want to integrate. So the only thing you can mess up at this stage is to put the wrong thing over the wrong fraction. And then plus 10 over 9 over x plus 4. We do have to be careful on the first integral because, so you can take out the 7/9, and then the integral of 1 over 2x minus 1, there should be a 2 in the numerator, so a 1/2. So I'm doing u substitution, but doing it in my head. Absolute value of 2x minus 1 plus, there's no way I'm fitting all this. All right, hold on. Let's move her over. It's like easily my favorite part of using the iPad for this instead of the whiteboard. Plus 10/9 natural log absolute value x plus 4 plus c. So I think that's what we get. So I mean, I should probably rewrite it. Go 7 over 18 natural log absolute value of 2x minus 1, and then plus 10/9 natural log absolute value of x plus 4 plus c. All right, I think that's our answer. Should we try to check that? Let's try. Let's see what we get. Again, I think the best way to check your answers on these is to just be sure that you did it right. So integral of 3x plus 2 over 2x minus 1 and x plus 4, comma x. So 7 over 18, natural log absolute value, 10 over 9, yes. All right, let's try another one. Big advocate of, you do the problem and then you go to the calculator and check it. Like, I think that's easily the best strategy that we have. All right, so the one thing you do want to check, like, is it a proper fraction? But this is definitely a proper fraction. How much space do I have? All right, I have like a good amount of space. So I'm gonna do my ABC thing because there's 3 factors this time. Let's say a over x, b over x plus 3, plus c over x minus 2. Good grief. Okay, so we got to do this. I'm gonna need a different color highlighter too because now there's 3 of them. All right, so what's underneath a? It's x. What makes x equal 0? We're gonna let x equal 0. It's gonna give us a. We go over here and we cover this up. Everything else is 0, so we get -2 over 3 times -2, -6. So we get 1/3. Okay, now we're gonna do it again. So we let, what makes that equal 0? -3. So x equal -3. We're gonna be solving for b because it's underneath b. We go over here, we cover this up, and now we're gonna replace every x that we see with -3. So it's 4 times 9 is 36, minus 3 is 33, minus 2 is 31, over, all right, we're covering up the x plus 3, so we got -3 and -5 is 15. All right, so it's not a common denominator, but I could write 1/3 as 5/15 and it would still work. Still not sure that's actually like a hard, fast rule, but I kind of like the idea. All right, what makes this 0? X equals 2. So we're going to be solving for c. We go over here, we cover this up, and we're going to replace every x that we still see with a 2. So that's 16 over 2 times 5 is 10. All right, I mean, I can write these with a common denominator. So, I mean, I'm not like super bothered by it no matter what. Oh, wait, this simplifies into 8/5. Oh, it's even easier. I can just use 15 as my denominator. So this may be a rule. All right, so now our integral. So I often just write the answer, right? So like I need to integrate f of x dx, right? And so I'm looking up here at this, right? Because I know all my values. So I know that like a is 1/3, and then I'm going to integrate 1 over x. So I'm going to get 1/3 natural log absolute value of x. Okay. I know that b is 31 over 15. Okay. So 31 over 15. And then I integrate 1 over x plus 3, which is the natural log of the absolute value of x plus 3. And then c is 8 over 5. And like maybe I need to clean this up. I don't, but maybe I would, and then I would just clean it up. But this is like way more efficient than like rewriting everything and doing that. So it would be the absolute value of x minus 2, and then plus c. Should we check? I guess so. Let's see. It's just so disappointing when it's wrong. Like you should always check, but like the reason I don't want to check is I don't want to see that it's wrong so that I have to fix it. Wine, x times x plus 3, x minus 2, comma x. 31 over 15 goes with x plus 3. 8 over 5 is going with x minus 2. 1/3 is going with that. We got it. All right, let's go back. Let's do the last one. This will be the last of our non-repeating linear factors. So non-repeating means that each of the factors in the denominator is to the first degree, right? If we had, for this next example, if we had quantity 3x plus 1 to the 5th, that's a repeating factor. It happens 5 times. If we had quantity 3x squared plus 2, that's not a linear factor, that's a quadratic factor. So these are non-repeating, meaning they're all to the first power, and they're all linear. You look at them and you're like, that's a line. So that's when this method will work, the cover-up method. It'll like be helpful in other scenarios, but this is when it works. So why can't I write 3x plus 1 plus b, aha. It's when I get too close to the edge, but it's like, just where I live my life, you know? All right, so here, what makes that equal 0? Let x equal -1/3. We're going to be solving for a. And this seems like it's going to be unpleasant. So we cover this up. -1/3 is just like not a thing that you wake up thinking, I'm going to plug that into everything I see today. -2/3 minus 5 over -1/3 minus 4. All right, so -2 minus 15 is -17 over 3 over -12, -13 over 3. So 17/13. Yay. I don't know. That might end up wrong because that's pretty gross. Here we go. X minus 4. What makes that equal 0? X equals 4. This will be solving for b. We go over here. We cover this up. And then if I let x equal 4, I get 8 minus 5 is 3 over 12 plus 1 is 13. So common denominator, so maybe it's not wrong. So what could go wrong at this stage? The main thing is that a is over 3x plus 1. So we need to do u substitution on that. We need to make sure the chain rule works out. So I'll like write the integral this time. So basically I'm going to end up with 17 over 13, the integral of 1 over 3x plus 1 dx, and then plus 3 over 13, the integral of 1 over x minus 4 dx. It's that first integral that I'm like a little worried about. Not really worried, but so this will be 17/13. I need a 3 on the inside, so a 1/3 natural log, absolute value. It's a lot of stuff you could forget, but don't. And absolute value of x minus 4 plus c. Should we clean it up? I guess so. 17 over 39. Eesh. Absolute value of 3x plus 1. This is like the place you run into these functions. You know, like, what's the application of these exact functions, not that much, but really good practice for things you'll do later. All right, should we check it and see and hope that we're right? Actually, I guess we should check it and not hope we're right. We should check it and know that we're either right or wrong. Integral 2x minus 5 over 3x plus 1 and x minus 4. And then our variable is x. Why do you have to do this? All right, so the exponents become coefficients, and then multiplication inside becomes addition between. Can I expand this? I don't think I can. Oh, yes. Geez, like in years, I've never thought to try to do that. So 17 over 39, natural log of 3x plus 1, 3 over 13, natural log, absolute value of x minus 4. We got it. All right. Also, we learned a new trick. You can expand those things when the can we always do that? Let me go up and get that other one. Where was it? It was this one, right? I was like, this is the worst. Can I expand this? I can, sort of. So it didn't pull the 2 down and give you 2/3. It gave you natural log quantity squared. Not really the end of the world. You just have to know some of the properties of logs, but you should know all the properties of logs, right? Because like you're becoming this calculus expert. All right, so let's go back to this. So you can do some screenshots in the event that you want. I cannot get them all on one page. So this is one of them. Take your screenshot. And then here's another one. Take your screenshot. And then, all right, I'm gonna end this video here and I will be back to do some more that are gonna be a little bit different. But if you're in Calc BC, these are the only ones that you need. You only need to know how to do non-repeated linear factors. This is it. This is some good examples of it. I will see you in the next video.